Hello and welcome to BirdBrained Explanations, where we just wing it. I'm your impeccable host, Vaishnavi. So, if you're a person on Earth, Mars, or anywhere in the universe really, you might have looked up into the night sky and thought, yo, who put those things up there? That's right, I'm talking about stars. Stars are essentially bright, giant balls of gas that float around in space, and as NASA would tell you, the most widely recognized astronomical objects, and represent the most fundamental building blocks of galaxies. That's fun and all, but what really is a star? Britannica.com answers that a star is any massive, self-luminous celestial body of gas that shines by radiation derived from its internal energy sources. So let's break that down. First off, stars are heavy, really heavy. Our sun alone is 333,000 times the mass of the Earth. Our sun is actually on the smaller side relative to other stars, so that's saying something. All of this mass causes it to have a strong gravitational pull, dragging along clumps of Earth and asteroids into its orbit. Over time, these form planets and become a solar system. So that explains the first part of this definition, but what about the self-luminous radiation part? To understand that, we must first figure out how a star is born. All stars start from clouds of gas called nebulous clouds, or nebulae. These clouds usually span across several light years and have enough mass to create thousands of stars. They mostly consist of hydrogen and helium molecules, as well as some other elements. Nebulae sort of just sit around in space until what is thought to be a gravitational or magnetic disturbance comes along, and then the nebulae starts to collapse. While the nebulae collapses, some molecules have more density than others, causing it to have an innate gravitational pull that bring the other dust particles or molecules closer together. As these gases collect, they lose potential energy, increasing the temperature. The gas collects, temperature increases, and the clouds start separating into smaller clouds, each hopefully becoming a star. The core of this smaller cloud starts collapsing faster than the outer parts, increasing the heat inside. At the center of all of this chaos, there's a tiny particle called the nucleus. Nuclei are subatomic particles in the center of atoms. They are dense and hold just enough electromagnetic force to keep atoms together. When these particles are put under extreme heat and pressure, they begin to split apart and release energy, a process known as nuclear fission. The amount of energy released by nuclear fission is so intense, it kickstarts fusion reactions and excess energy is released in the form of light. As Richard Brill put it, all stars are the result of a balance of forces. The force of gravity compresses atoms in interstellar gas until fusion reactions begin. And once the reactions do begin, they exert an outward pressure. As long as the inward force of gravity and the outward force generated by fusion reactions are equal, the star remains stable. All of this is the first stage in the life cycle of a star as it burns through helium and hydrogen in its atmosphere and eventually dies in a beautiful, blazing explosion called a supernova. All in all, stars are mesmerizing, fascinating, amazing flourishes of outer space. So the next time you see one, make a wish.